Hello everyone. This is our first chapter of class ninth physics, which is motion. Since you all have came from class 8, this chapter is very new to you. You might find terms which are hard, but if you pay attention, if you read the book basically, then it's no big deal. So let's begin with the chapter. Let's start by asking what is motion. We have known the term motion since 6th standard or maybe 5th standard. Motion is something when an object is moving with respect to time. We term it motion. We term that phenomena as motion. When the object or the body is moving with respect to time, that is motion. So that is the definition of motion. Here in the first paragraph itself, it has described all the phenomena in our everyday life where we see motion. For example, it has taken the examples of atoms, molecules, planets, and stars, which are in motion, which are quite good examples. But yeah, there is nothing in this paragraph or the paragraph preceding it. Just give it a read. You won't find anything objectionable or anything tough over here. So yeah, describing motion. In this paragraph, they have, described the term reference point very briefly. Like, what do we mean by a reference point? They have taken the example that there's a school which is located in the north of a railway station. This is the railway station, this is the school, and this is the north direction. The school is situated in the north of railway station, which is 2 kilometer north. So here what it is trying to say, that we are expressing the location of school with specifically the location of the railway station. And so the railway station here is acting as the reference point. So when we have to describe the location of the school, we take railway station as the reference point. We say the school is 2 kilometer north of the railway station. Here the railway station is the reference point. That's all. I don't think that you find anything tough over here. This is a very silly explanation. So yeah. Now, our next topic is motion along a straight line. It is a very simple topic, but most of the students find it very complex. Believe me, there is nothing in this page. You'll find it a very easy topic. So let's just look at it. What is there? Basically, it is trying to tell us the difference between distance and displacement. What do we mean by distance and what do we mean by displacement? So we know that distance is the total length of the path covered. Distance is the total length of the path covered, and displacement is the shortest distance between the initial and final position. Now, what do we mean by this? Let us clear it with a bit of detail. Let us look over here. See, suppose there is a school. This is a school. This is your home. Now, here, this distance from directly from your home to your school, this is known as displacement. And suppose you get out of your home and just go to your school this way, and then the distance becomes the length of this path. This is the distance and this is the displacement. So displacement is the length of the shortest path. You can see here that this is the shortest path between the home and school. There is no other path which is shorter than this. That is why displacement is the shortest path between the initial and the final position of the body. That's the basic difference, and we will look what are scalar and vector quantity a little later in this chapter. So yeah, we will see that later. Now let us look at this example. See, suppose we are starting from O, we are moving to A, which is 60 kilometer. This is a kilometer scale. You can see that we are starting from O, reaching A. How much distance we have covered? 60 kilometer. You can see here. Now we are moving. Yeah, sorry. We have covered a distance of 60 kilometer. And how much displacement have we covered? Displacement is also the same as 60 kilometer. Here the both distance and displacement is same, 60 kilometer, which can be displacement can be equal to distance, but usually displacement is shorter than distance. Yeah, displacement can be 0, but distance cannot be 0. We will look at these facts later when we will study scalar and vector quantities. So yeah, suppose now from 60 kilometer, the body moves back to B. From O, it started, reached A, covered a distance of 60 kilometer, and the displacement is also 60 kilometer. It moved back to C, covering how much? 25 kilometer, covering a distance of 25 kilometer, that is from here to here. So how much distance now we can say it has covered? That is 60 plus 25, which is 85 kilometer distance it has covered. But now when we talk about displacement, we count displacement from O to B. From O to B, this is our displacement, because it is the distance between the initial and the final position. So that is the definition of displacement. Here the distance is 85 kilometer, but displacement is only 35 kilometer. Only this much displacement has been covered. So this is the difference between this is the difference between distance and displacement. Now let us look at another thing. Suppose it has started from O, moved to A. We have seen how much distance and displacement it has covered. They are same, 60 kilometer. It moved back to B, then it moved back to C. Then the same thing will happen. Here the distance would become 10 more, that is 95 kilometer here from O to A, and then back to C. And displacement here would be 25 kilometer, you can say. And finally when it comes back to O, from A back to O, how much distance has it covered? Distance would be 60 when it is going to this side, plus another 60 when it is returning. That is the 120 kilometer. 120 kilometer of distance it has covered. But when we talk about displacement, how much displacement it has covered? I know you can now say how much displacement it has covered, because you are pretty much clear with this. From O back to A, displacement would be 0, because here the initial and final position are same. The position are same, so here the displacement is 0. We say that the shortest distance between the initial and final position is known as displacement. Here the initial and final position are same, so displacement is 0, because apparently here no distance has been covered. So displacement is 0, but distance is 120 kilometer. Okay, so this was the whole thing they have tried to show in this page. They have told us all the circumstances that we have discovered. We are not taking activity over here. We will make separate videos for activity once this chapter is over. So now, yeah, let's go forward. Now our next topic is uniform motion and non-uniform motion. What do we mean by uniform and non-uniform motion? We know the meaning of uniform and non-uniform motion since class 7. But now let us recap it again over here. It is saying that when a body covers the same distance in equal interval of time, then it is in uniform motion. And if it covers unequal distance in equal interval of time, then it is non-uniform motion. Now to make it more clear, let us look at an example over here. It is given that a person travels, or an object travels 5 meter in the first second, another 5 meter in the next second, another 5 meter in the third second, and the last 5 meter in the fourth second. So here we say that the 5 meter distance is covered every second. Okay, so the body is in uniform motion. Same distance in equal interval of time. How much is the interval? 1 second. So the body is in uniform motion. Now the opposite of it is non-uniform. When the body covers unequal distance in equal interval of time, then it is in non-uniform motion. Or you can say it like this: if a body covers equal distance in unequal interval of time, this is also non-uniform motion, but we take the former as the most appropriate definition of it, non-uniform motion. Now our next topic is rate of change of motion, or the rate of motion, which we call speed. We know what speed is. Speed is the rate at which the body is moving. The rate of movement is known as speed. That is as simple as that. There is nothing in speed to discuss. Nothing. Velocity is something which you find fascinating, which is quite interesting, but speed is just the rate at which the body is moving, irrespective of the direction. Now let us look at what do we mean by scalar and vector quantity before starting speed. Now first see what do we mean by scalar and vector quantity. Let us get to it. Now scalar and vector. Scalar quantity does not depend on direction. It has magnitude and no direction. Vector quantity has magnitude and direction both. So yeah, this is very simple. See, vector quantity over here is given in this standard. You have to learn this definition of vector only, but when you come to higher standard, you will find vector as a separate chapter, and it is a very vast topic. So here for you all to understand vector, it is just some quantity, some physical quantity. What do we mean by physical quantity? Speed, velocity, distance, displacement, all these measurable quantities, we call them physical quantities. And those physical quantities which has both direction and magnitude, we call them vector quantities. And those which with only magnitude, that is the numeric value, is known as the scalar quantity. They don't have any direction. Vector quantities have direction. Scalar don't have direction, obviously. So yeah, Let us look at what do we mean by scalar and vector with example. For example, with the help of distance and displacement. With the example of distance and displacement. Suppose this is your distance and this is your displacement. Now, what do we mean by scalar and vector quantity? We say that distance is a scalar quantity and displacement is a vector quantity. What do we mean by that? Now let us look what do we actually mean by when we say that this is a physical quantity, which is a vector quantity, and this is a scalar quantity. Distance is a scalar quantity because it has magnitude only. Here we have seen that in this example, that here the distance was 60 kilometer, here the displacement was 60 kilometer, which was equal. Displacement depend on direction because displacement is a vector quantity. So displacement was depending upon direction. That's why when it was coming back to 0, this distance was 120 because it was independent of direction. And when we talk about displacement, when we go here, it was plus 60 kilometer, and when we came back, it was minus 60, which came to 0. This is the actual meaning of scalar and vector quantity. Vector quantity has direction, scalar does not have any direction. So that is how it became 0. Now I hope that this topic is clear for most of you all. I hope all of you are clear with it. So yeah, let's go.